All right, so here is the final example from section 4.5 that I wrote on the board incorrectly when we were together. So it's typed properly here, so we're going to solve this equation involving two roots, and as I said in class, this process is going to require us to square both sides on two separate occasions. So what you want to do is you want to isolate one of the radicals. I am going to choose to isolate the first one, the square root of 2x plus 3. So in order to do that, I am going to add the square root of x plus 1 to both sides, as I am doing now. And so what I have is the square root of 2x plus 3, and that is equal to 1 plus the square root of x plus 1. Now, as we did in class, and as I'm hoping you did very well on the tests that I just gave you, you are now going to square both sides. So here I go. I'm squaring both sides. Square the left, square the right. Now, squaring the left, that's the easy part. When you square the square root of 2x plus 3, you just end up with 2x plus 3. And so, voila, one of our radicals is gone. On the right side of the equation, I have a binomial that I need to go ahead and multiply. So if you don't mind, I'm going to go over to the far right side of the screen and treat this as my scratch paper. So I'm going to multiply 1 plus the square root of x plus 1 times itself. And when I do that, I employ foiling, which is first outers, inners, lasts. My firsts give me 1. And we did this great in your notes. The only problem when we did this problem in class was that I wrote the problem wrong, one sign, and it made all the difference. And so there's my inners, give me square root of x plus 1, and then my lasts give me the square root of x plus 1, but since there's two of them, squared. And so simplifying a little more, we've got two of these square roots, so that is 2 square root of x plus 1s. And then out in front, I've got this 1. Now, those are not like terms. Do not add the 1 plus 2 and get 3. And then the square root of x plus 1 squared is x plus 1. So one more thing to do here. I've got 1 plus 1, that is 2. And then I've got plus x, and then plus 2 times the square root of x plus 1. So I'm going to take this right here, and this becomes the right side of my equation. So that's just my scratch work. So if you allow me a moment, I'm going to write that over on the equation we're working with. Okay, so you can see at this point, one of the square roots is gone, and I am left with the square root of x plus 1. And so now I have to do the whole thing again. So I need to isolate the term with the radicals. So I am going to subtract the x, and then I'm going to subtract the 2. And what that does for me is it gives me 2x minus x is 1x. 3 minus 2 is plus 1 is equal to, this cancels, and I have 2 times the square root of x plus 1. Okay, everything's going according to plan. Again, we are just having to do what we did in class successfully twice. And so now I'm going to do the same thing we did. I want to get rid of the square root of x plus 1, so I'm going to square both sides. Square, square. And so x plus 1 squared, if you need to, go to your scratch work. You're going to FOIL. I'm going to just cut to the chase here. X squared plus 2x plus 1. When I square the 2, you get 4. And when I square the square root of x plus 1, I just get x plus 1. We're almost done with this problem. I know it's been a long road. These problems do take a little bit of time, but have a little patience. I know all of you can do this. And so this is a quadratic because I have a second power right there. And so I'm going to get everything on the same side of the equation by subtracting the 4x and subtracting the 4. I'm going to move over to the center of the screen, and I've got x squared. I've got minus 2x minus 3 equals, and then these cancel right here, and I just have 0. This is a quadratic equation. You are welcome to either factor or use the quadratic formula. I am going to factor because I see that it does. The two factors of minus 3 that add up to minus 2 are negative 3 and plus 1. And so that means you've done this dozens and dozens of times, I'm sure. That means that the two values that potentially will work here are 3 and negative 1. With every square root equation, you need to make sure you check by plugging these values back into the original equation. So I'm going to start with the 3. I've got the square root of 2 times 3 plus 3 minus the square root of 3 plus 1, and I want to know, does that equal 1? Well, this here is 6 plus 3, square root of 9. This is square root of 4. Square root of 9 is 3. Square root of 4 is 2. That does indeed equal 1, so we're good to go. This is a fantastic first answer. Sometimes they both work, sometimes neither will work, sometimes only one will work. So I'm going to do the same thing with negative 1. I've got the square root of 2 times negative 1 plus 3, and then minus the square root of negative 1 plus 1, and I want to know, does that equal 1? So this first one, that's negative 2 plus 3, or square root of 1. This is negative 1 plus 1, or square root of 0, and that indeed does equal 1, and so the second one checks out. So both of these are answers. We've got negative 1 and 3 as our set. So you can pause, you can rewind, you can look at that. Now what we're going to do is this. This is problem 84 on the Chapter 4 review on page 333. I want you to pause the video, and I want you to write that problem on your notes, and I want you to take a few minutes to work through it. I'm assuming you've paused. I'm hoping you did. I hope you took the time to take this seriously. Here we go. I'm going to work that problem. And so on this problem, you notice that the first radical I'm going to get rid of is already isolated. So what I'm going to do straight away is first I'm just going to rewrite the problem because I'm trying to create as little mess as possible. I am going to square both sides. So here we go. Square the left, square the right. Squaring the left is the easy part. The square root of x minus 2 squared is x minus 2. I'm going to go to my scratch paper, and I'm going to multiply the 5 minus the square root of x plus 3 times itself. And when I do that, my firsts give me 25. My outers give me minus 5 square root of x plus 3. My inners give me minus 5 square root of x plus 3. And then my lasts, a negative times a negative is positive, the square root of x plus 3. And since there's two of them, it's squared. And so when I add my like terms, negative 5 and negative 5 is negative 10 square root of x plus 3's. I've got my 25 out in front, and the square root of x plus 3 squared is x plus 3. So we're almost done. I'm going to bring add the like terms, so I get 28 plus x minus 10 square root of x plus 3. Great. So I come over here, 28 plus x minus 10 square root of x plus 3. All right, so again, I've gotten rid of one of the radicals. Here's the second one. So I have to isolate it. So I'm going to subtract the x. And then I'm going to subtract the 28. Now, the nice thing on this problem, as opposed to the previous problem, is rather than having a binomial on the left, remember binomial means two terms, the x's here cancel, and I just have negative 30. These cancel, and I have negative 10 square root of x plus 3. If you saw to do this, you can divide both sides by negative 10 since it goes in, but I'm not going to assume because we haven't done that before. So what I'm going to do now is I'm going to square both sides again in my effort to get rid of the second radical. And so the square root of negative 30 squared is 900. The square root of negative 10 squared is 100. And the square root of x plus 3 squared is x plus 3. This is a linear equation. I'm ready to solve it. So what I'm going to do is distribute. So this one ended up with a linear equation. The previous problem ended up with a quadratic equation, but that's fine. You know how to solve linear equations. I am sure you have done your share of linear equation jail. And so we've got 600 is equal to 100x, and when I divide, I'm doing all the steps for you. That way you can make sure you're doing everything right. We get x is equal to 6. Last step, last thing to do is to make sure that that checks out. So here we go. I've got the square root of 6 minus 2. I'm plugging 6 back into the original equation. And just to make sure that this checks out, 6 minus 2 is the square root of 4. 6 plus 3 is the square root of 9. And I get the square root of 4 is 2 is equal to 5 minus 3. That is a true statement. It checks out. So my solution is 6. So do a couple more problems from the 4.5 homework that involve two radicals, and I will see you Monday. I look forward to it.